In this lesson, we're going to look at distance time graphs for a body moving with a constant speed. So let's imagine that we have a walking race over a distance of about 120 meters, and we're going to record the distance covered by each person, for example, every 4 seconds. So the first person starts, and every 4 seconds we measure the distance and we plot those points on a graph. Okay, so you can see the graph opposite. We have time going along the horizontal axis, and then along the vertical axis we have the distance covered. So let's imagine that this person in the first 4 seconds covers a distance of 30 meters. In the next 4 seconds reaches 60 meters, then after 12 seconds 90, and then after 16 seconds 120 meters. So we join the points, and the first thing we notice is that we have a straight line, and this will always be true for any object that is moving with a constant speed. The distance time graph will always be linear. It will always form a straight line. Now, how can we calculate the speed of this person? Well, you can always find the speed from the graph, and the speed is equal to the slope of the graph, or the gradient of the graph. Now, to calculate that, we take a horizontal section, and for that horizontal change we find the vertical change. We measure the horizontal length, and that's equal to 12 minus 4, which is 8 seconds, and then the change in height, which is 90 minus 30, which is 60 meters. So in 8 seconds the person covered a distance of 60 meters, and the slope of the graph is equal to the vertical change divided by the horizontal change. In this case it is 60 meters divided by 8 seconds, which is equal to 7.5 meters per second. So this person is walking with a speed of 7.5 meters per second. Now then, let's take somebody else. Now we measure the distance covered for this person every 4 seconds. Okay, off he goes, and every 4 seconds we measure the distance that he covers, and the graph looks like this. So this time you can see that the slope is not as steep as the previous graph. What does that mean? Well, it means that the person isn't walking as fast. The speed is equal to the slope of the graph. The slope is less, so the speed is less. Let's calculate his speed. So we see for a horizontal change of 24 seconds, we have a vertical change of 30 meters. So in this case the speed is the slope of the graph, which is, let's make a note, slope equals 30 divided by 24, and if you get your calculators out you'll find that that is 1.25 meters per second. Finally, this person walking quite a lot faster than the other two, so we would expect this graph to be the steepest graph when we plot the distance covered against time. We plot his, and there you can see, right? In this case this person walks incredibly quickly. I don't think people can really walk this fast. So anyway, we have in a time of 8 seconds the distance covered is 120 meters. So here we can say the slope, let's change the color, equals 120 meters divided by 8 seconds, which is equal to 15 meters per second. He can actually walk faster than Usain Bolt can run, so we don't really believe that, do we? But anyway, this is just academic. So this graph is getting slightly messy, but the point we want to make here is that when we plot a distant time graph for any object that is moving with a constant speed, then the slope of the graph, that's to say the steepness of the graph, is a measure of the object's speed. The steeper the graph, the faster the object is moving, and vice versa. The more shallow the slope of the graph, the slower the object is moving. And just to make this point, that when the graph is exactly horizontal like that, then the object is at rest. So let's just briefly summarize that. For any object moving at constant speed, when we look at the distant time graph for that motion, then we can say the speed of the object is equal to the slope or the gradient of the graph. And the steeper the slope, the faster the object is moving.